Welcome in another episode of our Inside of Things show. Today we will talk about devices, and we will talk with our two guests. Please say a few words about him. Piotr.
Hi, my name is Piotr. I'm an infrastructure and DevOps evangelist at TTPSC. So my main focus is optimization. So I make sure that the deployments of the applications are fast and easy. I also have closer look to security aspects. So we are building the secure authorization and authentication systems. And my recent project is an innovation in the energy market. So we are just optimizing wind farms. So in real time, we monitor the wind farm and also look into the weather forecasts in order to make the grid work in a perfect balance.
Cool. Sounds like a really nice job.
Yeah.
Thank you. Łukasz?
Hi Paweł, Piotr, thanks for having me again in your program. My name is Łukasz Schulz. I am industrial Internet of Things evangelist in PSC, and I have a huge background in industrial automation. I think we can start with the main dish.
Cool. And I think that before we go directly into the devices, let's go a little bit higher, okay? Let's talk about the projects. I wanted to ask you, from your experience, about the projects, the IoT projects that you participated in, what are the commonalities, the most important commonalities and differences in such projects? Maybe Piotr, you want to start?
So IoT projects, they focus mainly on collecting data, somehow transforming this data, making a value of this data, and I think the value that we can extract from the data is the most important thing here. And in fact, the value that we take out of the data is what differentiates different projects. Because as you said, in the very base, it is very common to simply have devices which collect data. We store this data, we analyze this data, but what we get out of this data is what differs in the different projects. So, so for example, I was working for the project where the customer had a fleet of electric cars. Okay, and it was really interesting because they used the batteries inside these electric cars to power the factory. So, for example, if the car is not, or the electric vehicle is not being used and is fully charged, they use this energy stored in the battery to power the most critical machines. So the production was maintained. So we had to look closely to which vehicles are not being used and can be in turn be used to power these machines.
And it was kind of the backup source of power?
Yes.
Okay.
In terms of, if in the time where we had the outage or the blackout, no energy from the grid, they could just power this main machines to maintain the production.
I see. Łukasz?
Yeah, that's what Piotr said. Main commonality in all IoT projects is data flow. You always want to gather all the possible data and give them the right context by connecting them together. And this is the main commonality. But if you just look a little bit deeper, it completely depends what kind of data sources you are connecting. If you mean separate sensors, they can produce very little amount of data, and but it must be exactly every 1 second or even more often. And if you are communicating with bigger systems like ERP or MES, you just need to download it maybe one per half an hour, but it's a huge amount of data. It's like the connection to the whole database or data lake even somewhere. So it's always, the common ground is flow of the data. You need to think ahead before you start developing the architecture of the project, how you want to handle the streams of data, where to connect them, how to arrange them, to find the important information, changing the data into information by giving them context and filtering them out. So the operator, the human, at the end, see only what is really important for him to find how to tune the process. So that's how you need to think ahead, and that's where every project is a little bit different. You are using more or less the same tools, but you need to arrange them in a completely custom way to be sure that it gives you value at the end.
Exactly. Yeah, I totally agree. And pretty much you answered my next question, because I wanted to ask I wanted to ask for this beginning of this data flow process. Yeah. So for the devices, the data sources. Okay. How important in this flow for you is to understand those devices? How this adding the context? I really liked this sentence. How you said this. How important in adding the context to the data is to understand with what device we are dealing.
Yeah, it's very important. I think it's the key because, we talk about intelligent devices, smart devices, which collect data. And of course, the monitoring aspect is something we cannot exclude. But for example, if we want to control those devices based on the data they collect, so for example, the predictive maintenance or optimizing their how they work. But not all devices need that control, I think. So for example, if you only have a wearable which gathers the information about how people use those devices, we might not need to control them. But with this data, we can, for example, make a company think about improvements into these devices, so further improvements and the new versions of the products can be better and more suited for the end users. But I also would like to mention the security factor here, because the security researcher Mika Happonen said that if something is smart, it's vulnerable. Yeah. So it's even more important to understand what data we are dealing with and what data are we collecting, because maybe this usage information, this could be sent over the internet, no problem. If this data is anonymized, no problem. If maybe anyone, hacker, just gets in the middle and get the data that is being transmitted. But on the other hand, we might have a very strategic business data that we collect from the devices, and maybe this data is not even intended to leave the company, the factory. So we might just set up or build up the private cloud, or just provision the servers, the storage for this data. So I think the security aspect is also very important.
Yeah, of course, you also have the legal aspects of the data management. Łukasz, what do you think about this understanding the devices?
It is fundamental to know what the device is providing, what data it's providing to you. First of all, to adjust the bandwidth you require for reading. If it is like you are measuring temperature of environment, if you measure it once per half an hour is enough. Nothing important will happen. But if it's a temperature inside like a process chamber and you are producing like beer or something, it's very important to maintain it on the same level, and you need to measure it every second and react very fast if something happens. If it will be measurement of some electrical processes, it's like milliseconds. You need to be able to react every few milliseconds to adjust, maybe cut out something, maybe switch to another bus. So it's very important to understand what is the severity of the data, what are the thresholds that you need to react. And also, sometimes, if it is like a wearable, that's what you said, if it will be a smart band, the whole day you can be out of your smartwatch in the forest somewhere without connection. Doesn't matter too much if you just synchronize in the evening. So you can just store it locally, because it's not important to process those data in the real time. You are just storing it for the further analyze. But if some process depends, some alerts might be generated, you need to be always online. So it's very important to know what you are measuring. If this is a device that is moving, if the process depends on it, or it's just something in case problem happens, you want to just restore what was the history of it, then you do not need to process this every cycle. And in the same time, what Piotr also said, if you want to use AI, like artificial intelligence, some neural networks, algorithms for predicting something, you also not only need to read those data, but also prepare them, normalize, store them with the same timestamp, store them in the proper way so the algorithm can predict something, can adjust something. So it is fundamental to understand what the device, what are the data the device sends to you. You need to have it always in the back of your mind.
Yeah, and the question I immediately have on my mind is, who decide about that? Or maybe who is telling, in example, how often this data should be produced or stored, from the devices? Because let's imagine, the simple device, smart band, in example, So the smart band allows to send to the cloud, in example, or to any different solution that this guy is connected to, my body temperature once every half a second, okay, because it is capable of doing that.
Yeah.
But as we are saying, it's not really necessary to send it so often. So who decides that? When you starting the project, when you're talking with the customer, does customer always knows something about that, or he guides you, or it is you as architects, as someone who engage, that needs to read the documentation, need to know the device, or how does it look?
Not so much. Usually it's not us. There should be someone who understands really well the process, what he needs to have from it. It's like we are like the guys who can build the car, for example. Yeah, we can build the car, we understand how the car works, but we are not the best drivers. There is a driver who can tell us, okay, I need one more gear, I need to adjust the steering wheel control or something. He knows how it should act, we know how to prepare the engine behind it. So usually it is someone from the customer side. Sometimes they only just ask us, tell us what our competitors already do. They want to know our experience with dealing with similar processes, so they have the starting point, what they can expect, because they don't always have like imagination, what they can get from those really new systems. It is something new on the market, so they not always know how big they can dream, and we need to give them some inspiration.
Just to add to that, it's always good to ask the question. Do you really need this data? Do you need this data to be this frequent? And I had this on one of the projects where I just asked the question: do you need this data to be stored this frequently? And they say no one is interested to having this 10 data points every second. We can just reduce it to 1 second, and even for the data that is older than 3 months, we only need 1 minute resolution. So it's also our responsibility to challenge those requirements, maybe, because this also involves the cost of storing this data, analyzing and stuff like that.
Yeah, of course, because processing the data, storing the data always impact the costs of the project. Yeah, that's true. That's a very good point. Okay, but what was, let's say, the most exotic set of the devices in the project that you work on? You mentioned already the electrical cars and so on. So
that was one of the most interesting ones. But I also worked in one project where we had an Ubuntu running the Node-RED application. So it's quite uncommon to have a common operating system, Linux operating system. Usually we have embedded systems, embedded operational systems, and in this case it was just a computer attached to 0.7 megawatts generator. which was just reading the data straight from the generator, the power, the actual power, the target power, frequency of the current, and sending this using the MQTT. So quite uncommon, I think.
Yeah.
The other example could be
Is that wind turbines? Maybe those.
yeah, I mean, for the wind turbines, it was, in this case, we had a control partner. So it's like the data been sent to us. We didn't even know how they are gathering this information.
Okay.
It was just sent to us, and we were responsible for storing this and analyzing it.
Okay.
Okay.
And you, Łukasz?
I believe for me the most challenging and exciting was military vehicle. That was. I was working for a different part of transition technologies, and I was more on the side of collecting signals from various sensors, adding those sensors, connecting to the computer that was already built in this kind of tank. I don't know if I can tell the exact name, but it was kind of a tank with a huge cannon on top. And they wanted to have like a black box that will document how it was behaving when the driver was using it. So they wanted to check if the driver is using it properly and if something bad happens with the pressure inside, with the temperatures and the electrical side. And the main challenge was that we had to find, I had to find the sensors that can survive in the very rough environment, because the military people who were using it, and we wanted to see how deep was the pedal pressed, what was the gear, the steering wheel. So they do not care, they are washing it with the pressurized water, using all the dirty boots, etc. And also in the same time, I placed their industrial PC for collecting this data and sent them via GSM to the central server. And the main problem was also that whenever this cannon shot, it's like the huge impact on all the electronics. So all the sensors and the computer must have been military class, which are very robust for this pressure, acoustic pressure and rapid movements. Mm-hmm. So the computer was without any moving part, only passive cooling, etc. Then you cannot send a signal to GSM when you are inside the box. So we also found that the driver needs to open small lift and put the camera with a magnet, antenna with a magnet. So antenna was sending signal, and another antenna was gathering GPS position. So there was a lot of problems that maybe you would think only when you start processing every risks, you are finding more and more problems. So it was very challenging. I even remember that my boss at the time said that we have no experience, we cannot do it. But I convinced him, it's just like we normally do power plants. It's like a moving power plant. It's still the same philosophy. You just do adjust the devices that are producing data to this robust environment. And in the end, it works quite fine. We even had the pleasure to drive in it.
Oh, cool.
and then you just opened, we did it in the ThingWorks, one of the first applications in Poland. And you could see exactly in which moment where the tank was and what was the gear, temperature, speed, etc. It was very nice application. I was really quite proud. I don't know if I can say what was further, but but general application was nice.
Did you shoot the cannon?
No, unfortunately, no.
But you both mentioned something very interesting, that sometimes to get the data, some manual work is required. Yeah, I like to say that this is like human in the middle protocol. Yeah, because you need to pretty much do something. But from your experience, what is the most common protocols used for the device connectivity? And of course, sometimes you can decide. Yeah, if you connect devices indirectly, you just need to connect them, and then you can use this, in example, gateway that you are deciding to use because of something. Okay, this edge computing is getting more and more popular, of course.
Mhm.
Yeah. So you can decide which protocol to use to send, an example, to the cloud or to different solutions. Yeah, but you are dealing with the devices which are also capable of sending or being connected directly to some kind of a solution. So what are the protocols that you are using most commonly?
Okay. Again, the most famous word of IoT, it depends. It depends on which level. Because when you are connecting devices on the field, sensors and PLCs, still most popular protocol is Modbus. And I must say I hate it. Because it's very slow, it do not pass timestamp, it do not pass quality. It has a lot of limitations, but in the same time it's completely open, so everyone can, and it's quite easy. The frame, you can see the hexa frame and understand what's going on there. So it's very popular. It started in the 70s of the last century and still very popular. But more and more it's being replaced with better ones, and I believe the one that the future belongs to is OPC UA. This is the next step from PCDA, data access. Now it's UA, unified architecture.
And there was the HDA and alarms events in between.
Yes, historical data access, alarms and events, of course. Yeah. But the previous generation was very tied to the Microsoft space.
Yeah.
They was using those ActiveX and all the OPC was first all for process control.
Yeah.
But now it's open for Linux, it's open for everyone to use it. It's no longer under tight control of Microsoft. And since this decision, more and more companies, even the huge one from the industrial automation, adapt it. And it's very important that now for most of the PLCs, it's out of the box ready. You do no longer need to pay additional money or put something in between, like you said, these edge devices. Mm-hmm. But still, edge devices, I think, are returning. It used to be like the gateway, as you said, that was connecting via typical industrial protocols, some Profibus, Profinet, Modbus, CAN bus, etc., and then translating it maybe to OPC UA and sending it to the cloud or to your process center. But more and more, then it was way to install OPC UA directly in the sensors and send it to the cloud, or use MQTT, very good protocol and also gaining more popularity. But now again, the edge devices are coming back to the market because some actions, like the predictive maintenance, you do not want to wait to push the data to the cloud, perform some calculations and send it back to PLC. So the edge becoming more powerful and not only gathering, filtering this data, but also doing some basic algorithms on it to make instant decision for the most important part. So the model is trained in the cloud because it needs huge power to calculate everything, but the execution is normally sent back to the edge. But still, if you ask me what are the most popular protocols, definitely OPC UA. And MQTT is very nice, and I'm happy that it's gaining popularity. And also some classic REST API coming more and more to the industrial automation.
Yeah, and before we ask Piotr for the same, but I need to add that the direction you mentioned about the edge computing is exactly what, in example, the biggest cloud providers are thinking, because they continuously allowing users to use well-known cloud-native services. In example, in Azure, like Stream Analytics and I don't know, storage account, to be used on the edge, not in the cloud directly, but on the edge as well. Yeah. Of course, everything is, let's say, managed from the cloud level because it's still needed, but you have more and more possibilities out of the box to use on the edge.
I heard Cisco calls it fog. It's no longer cloud, it's a fog.
Yeah. Fog is also the very interesting concept that is in between the edge and the cloud, because the fog allows you to use the computing power from the devices that are not in use currently. They are not using the normal work. Okay, but so you can use them to calculate something. Yeah, but normally, if you, in example, has the manufacturing and the devices in the factory are working from 9 to 5, in example like humans, yeah, this fog does not exist because they are heavily used. But after this 5 o'clock, yeah, they are not doing the daily jobs. Okay, so you can use them to support your edge computing. So this is a really nice concept. Yeah, I agree with that. So Piotr.
Yeah, I just wanted to extend MQTT because it's great. It's low latency. It's fast. But I think the most important thing here is that it guarantees the delivery. I mean, it can guarantee the delivery of a message. So if you want to send a very critical message that needs to be delivered, for example, to cloud or another system, you can use MQTT or AMQP because they use the so-called quality of service. You can just make sure that the data that was sent to the broker, because we are talking about the publisher and subscriber mode. So we have a publisher which sends the data to the queue on a specific topic, and a subscriber which subscribes to the topic and gets the information that was sent to this specific topic. And we can make sure that if the subscriber is for some reason not connected to the broker, the outage, it could be an application error, wherever, the data that was sent to this topic will be preserved until the subscriber connects again. So it gets the message even if it's not connected. So yeah, these two, MQTT, AMQP, as you said, REST, but I think because the HTTP protocol puts a huge overhead, because every time you want to send the data, you need to create a connection. Yeah. So it's quite a big problem, and it's ineffective when we are dealing with a huge amount of devices. So what we could do, we could, for example, use WebSockets, or just ThingWorx native always-on protocol, which works based on WebSockets. And with the WebSocket, you just create a connection at the very first time, and then just prevent this connection until it gets disconnected. So you need to say, okay, I want to just disconnect. If you don't say it, if you don't invoke this action on the device or the system, the connection will still be there. So if we want to send the data, the connection is already there, so we do not have this overhead of creating this connection over and over again, what we have in HTTP.
Yeah, it's about this MQTT and AMQP. More and more very popular frameworks support in example persistence by default. So you are sure that someone that is intended to get the message will get this message at some point. It is very interesting. So to wrap up, there are some layers of the IoT projects that are very common, okay, from the, in example, tools that we are using to achieve our goals in the project. But there are different domains, different projects where crucial to achieve the success is to understand the devices, to understand what kind of data are produced by these devices. And it is really exciting, because now I think about it that, even if you are at some level of technical knowledge and you think that, okay, now I'm a little bit bored because it's a next project that I'm going to use, IoT Hub, stream analysis and so on, Azure on AWS or ThingWorx or whatever. I know all the stuff, so I will get bored. Not really, because you will be hit by the device you see first time in your life, and you will see the protocol that you have no idea about, and the play starts again.
Yeah, definitely.
Thank you. It was very interesting. I hope you will visit us again, and thank you guys, and see you in the next episodes.